Good morning, everyone. I did want to spend some time with you looking at the information that is in Chapter 1 in your textbook. Again, there's a photo of the textbook right under the instructor information on the course page on the 131 page. Chapter 1 is titled Chemistry in Our Lives. And one of the very good things that your textbook does is for every chapter, it links what we're talking about in that chapter to a job in the medical field. And so the very first thing this one talks about is having a career in forensic science, and it looks at some of the things that forensic scientists look at during the course of their day. The first section in your book is titled Chemistry and Chemicals. And so in the first section, they define for you what chemistry is. And they define it as the study of the composition, structure, and properties and reactions of matter. And then they go on to explain what matter is. Please make sure that you get the definitions of chemistry and matter down and you understand those very well. Then the next thing that the chapter talks about is what by definition is a chemical. And it defines chemicals as substances that have a constant composition wherever you find it. And so it gives you a list of chemicals there, some that we use in our everyday lives. The next section in chapter 1 talks about the scientific method, and it goes on to explain the steps of the scientific method. Please remember that all the scientific method is a way to analyze a problem and come up with an answer for whatever your problem is. There are several steps that you need to be familiar with. You need to know what observations are. You need to know what a hypothesis is. And normally the definition that students give is that it's an educated guess. Well, what kinds of things make it educated? Is it educated because it graduated high school or graduated college? So why is it an educated guess? You need to know what an experiment is and how it tests a hypothesis. You need to also know how to come up with a conclusion or come up with a theory. Now, you also need to realize that you use the scientific method in your everyday life. And then it gives you some study questions. Your book is really good about giving you important information on the sides. If you're using the e-text, in the e-text, it has some try it first problems, and then it also has some practice problems. And on the e-text, you can just click and it'll show you the answers. In your textbook, though, the answers are at the end of the chapter so that you can check yourself to make sure you're understanding. In section 1.3, it goes on to talk about how you should study and learn chemistry. It specifically talks about strategies that you should use to improve learning and understanding. There are some very important tips, like don't just keep reading over your notes. Notes are a good thing, but if you are just reading over them and you're not trying to apply the information that's in them, then you're really just memorizing information. You aren't learning how to apply it. And we need to be concerned with application. The second thing that your book mentions is that you need to ask yourself questions as you read. So as you're reading through the textbook, make sure you're asking yourself questions related to what you're reading to make sure that you really understand the information that it's giving you. You can do a self-test by using the quizzes that are given. There are practice problems at the end of the chapter. The answers for half of them are in the book so that you can check yourself to make sure you understand the information before you do your homework, before you submit your quizzes, to make sure that you get a really good understanding. Make sure that you don't try to cram everything at one time. Study a little bit every day to make sure that you really understand the information and you're not just memorizing the information. And then it also says for the fifth tip to study different topics in a chapter and relate new concepts to concepts you know. So by engaging what you already know with what you're learning new, you will be able to apply or get that information to go into your long-term memory. Your textbook also talks about features that are in the book that will help you categorize information, like the key math skills, the core chemistry skills, the review, the engage. Make sure you're reading those things that are on the side of the page. Especially look, if you're using the e-text, if you look at the interactive videos, there's a lot of helpful information that's given in those videos that will help you to do your best in the class. And then in section 1.4, that's where we deal with your key math skills that you'll need for chemistry. You'll need to know place value. You'll need to know how to use positive and negative numbers and calculations. You'll need to remember those rules. Negative plus a negative is always going to give you a negative answer. Positive plus a positive is always going to give you a positive answer. But what do you do when you're adding a positive number and a negative number? You need to know how to find those answers there. And so in that next section, it talks about how to find those answers. You should also be familiar with how to calculate percentages. Remember, every time we're doing any kind of percent, you're always going to do the part that you're asked about. So it's part over the whole, the total sample that you're looking at. And then if it asks you to find a percent, then you take that fraction that you have, you divide, you multiply that answer by 100% to get your percentage. It also talks about how you solve equations, and we're just talking about basic solving equations like you did in Algebra 1 in high school. One equation that you will specifically need to be able to solve is the temperature equation, where you convert from degrees Fahrenheit to degrees Celsius. You will need to be able to manipulate the equations to go from either degrees Fahrenheit to degrees Celsius or from degrees Celsius to degrees Fahrenheit. They also give you a sample problem about how you solve other kinds of equations, and there will be lots of different kinds of equations that we'll use during the course of the semester. You will also need to be able to interpret graphs. You'll need to also know how to draw graphs. And I can talk with you specifically if you need to know how to draw graphs using Microsoft Excel. Please remember, you do get Microsoft Office from the school for free as part of your tuition. And I can tell you how to download that. And on your graphs that you download or that you make, you will have to include the features of a graph, like you'll need to have a title, your axes, the vertical axis and the horizontal axis, they will need to have titles. You need to be able to interpret what you're seeing on the graph, and graphs are representations that help you explain data very easily, so you'll need to be able to interpret whatever you see on a graph. And in the very last section of chapter 1, we start talking about how you write numbers in scientific notation. The biggest thing I need to say with scientific notation is, remember, in order for it to be proper scientific notation, you can only have one number in front of the decimal. If you have more than one number in front of the decimal, you'll need to move the decimal. And if you move the decimal, you have to change the exponent. Generally, the rule that I try to teach students is if you've got a big number and you make it small by moving the decimal, then your exponent's going to be positive, or you'll need to add numbers to your exponent. If you have a small number and you're making it larger, then your decimal will move to the right. And because it's moving to the right, you'll need to subtract numbers. Remember, with scientific notation, the number that comes in front of the times 10, your coefficient, that number has to be between 1 and 10. So again, only one place to the left side of the decimal. And Then when you have the times 10, the exponent on that 10 tells you how many places you move the decimal. It does not tell you how many zeros. So please make sure you are able to go between standard and scientific notation. It also talks about how you enter scientific notation on your calculator. All of your calculators, if they are scientific or graphing, do have particular buttons to enter scientific notation. If you have a question on how you should enter it on your specific calculator, please make sure you bring your calculator with you to the Collaborate sessions, and you can hold it up to the screen and I'll look at it to help guide you in entering your answers. But your book does talk about how to enter it on scientific calculators. If you've got any questions on that, please let me know. On page 20, you'll find the concept map for chapter 1, which hits the major points and major things that you need to be familiar with in the chapter. On pages 20 and 21, it does give you a chapter review, which goes over each section to make sure you understand the key important information from those. Following that on page 21, you'll find your key terms and your math skills that you'll need to be familiar with, which go into a little more detail and have a few more examples. And then on pages 22 and 23, continuing on to page 24, you'll have some extra practice problems. Again, half the answers for those practice problems are at the end of the chapter, and you'll find those answers on page 24. If you need me for anything, please let me know. If you've got any questions, or you don't quite understand something, please use the Collaborate session to help get your questions answered. I hope you have a wonderful rest of your day. Thank you so much, and reach out if you need me.